Okay, that is so tiny. I thought I remembered it being larger, but oh well. Okay, so today I was meant to start right into chapter 9, but as I was looking at it, I realized that we need a little bit of two of the sections that are in chapter 8 in order to make this go smoothly. So it may be review for some people, but I wanted to make sure to put it in here and just have you do one assignment off of it before we jump in to chapter 9. So we're going to do a little bit from 8.1, which is square roots, mixed with a little bit from 8.3, which is simplifying. Okay. So when it comes to square roots, this entire square root so this entire thing is called the radical. That's our radical symbol. In this case, it's a square root. And then the 16 underneath is called a radicand. So it's the whole thing, radical symbol, and then the 16 is called a radicand. Are you able to find the square root on your calculator? Yeah. Okay. So the calculator is extremely helpful in finding your square roots, but it is also helpful to be able to identify. Okay. Yeah, no, squares for what we're about to do is fine. We're not, had we not sort of truncated the term, I would have done cubes, but, and you'll get some of those in the material from chapter 6, because we've got those sum of cubes and some of difference of cubes. Right? But for this particular last couple of weeks, it's really going to be perfect squares. I'm going to say memorize, but really, I mean, can you recognize them? I had to know them through 25 at one point in my math life. I think right around 7th or 8th grade, they made us memorize them through 25. And I found it helpful, but I do math, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. And most people I know have either had to do up to 10 or some possibly through 12. Again, $17 squared is $289. 18 squared is $324. 19 squared is $360, $361. And 20 squared is $400. So basically, for this class, what becomes helpful is knowing these last two rows, really. And as a piece of advice, what I usually say is if you can pick out 2 or 3 of these that you just say, okay, I'm going to get to know them. I'm going to get to know 15 squared, 18 squared, and 20 squared. If you just pick out 3 that you get to know better, it makes the others easier to find. Because if you know, for example, that 18 squared is 324, you'll know 17 squared has to be less than that, right? So 17 squared has to be between 225 and 324. And so when forced with an answer or forced with a number, you can at least decide if it's between those two. So, okay. Now, that's not to say you won't have a calculator. You will. So you can use your calculator to find the square roots. One's like the square root of 121, or the negative square root of 49. But how do you do the square root of a 0.64? Or the square root of 1 over 25? Now, there's no doubt in my mind that the square root of 121 is 11, and many of you would know that the negative square root of 49 would be 7, but you got to put the negative out front. Square root of 0.64. I can do this, but many of you may reach for a calculator. The square root of 64 is 8, and the 2 decimal points, 0.64, are cut in half, so this is 0.8. You can always check that on a calculator if you're unsure. The square root of 1 over 25 would be the same as the square root of 1 over the square root of 25, which is 1/5. Some square roots we need to approximate. Because they are irrational. Meaning they do not land on perfect square roots, but rather they are decimals that do not end or repeat. For example, the square root of 7, or the square root of 12, negative square root of 12, or the square root of a 4.25. These must be done on the calculator. So second square root 7, and you see how the decimal places carry out and fill up your calculator. This is an irrational number, meaning it does not end or repeat. It cannot be written as a fraction. And when we find the square root of 7 to 3 decimal places, this would be a 2.645, and that 7 is going to round that 5 up to a 6. The square root of 12 would be about a 3.464, but I need to put the negative out front. .062. All of those had to be rounded. That doesn't always happen. All right, any questions so far? Summer, am I going okay? All right. Okay. Okay. So we do need to watch out as we're doing our mathematics for what are known as imaginary numbers. Imaginary numbers are square roots of negative numbers. A negative square root of 25 would be a negative 5. But the square root of a negative 25 is imaginary. There is no number that can be multiplied by itself to get a negative 25. If I have a 5 and I multiply it by another 5, that's 25. And if I have a negative 5 and I multiply by another negative 5, that's still a positive 25. Squares are always positive. And cannot be negative. So if you're trying to take the square root of a negative number, that's an imaginary answer. All right? Okay. The other thing from 8.1 is Pythagorean Theorem. That's used a little bit in this section. Do you remember enough about that? Do you feel fairly confident with that one, Summer? Okay. So I won't do a lot of review there unless you feel that that's a particular. The other one is the square root property of equality. I'm going to call this a common sense piece. And this says if, I should put it in there, if the square root of A is the same as the square root of B, then it must be true that A is the same as B. Oh, okay, great. All right. Questions on any of that 8.1 stuff? Okay. All right, and the homework that I assigned out of that is just a lot of finding square roots, a lot of calculator work. There's some Pythagorean theorem in there, and some identifying of rational, irrational, and imaginary. The 8.1, yeah. Yep, this is 8. In what? You should have an 8.1 and 8.3 that's due on Thursday. Uh-huh. Wednesday. Oh, maybe the 8.1 and 8.3 will show up a little bit later today. I'll double check for Thursday. I may have scheduled it so it wasn't visible right away. I can imagine I would do that. Yeah. Because I edited it like Sunday night, so I might have gotten a little crazy with it. Right? Okay. So what I really want you to be able to do out of 8.3 is to be able to simplify your square roots. This section deals with simplifying all different kinds of roots. We just really need you to be able to simplify a square root. You may or may not have done this in the past. I'm not entirely sure, but we are going to practice it here. So what this does is this gives exact answers to irrational square roots. We do not use decimals here. You can think of this as like when you reduce a fraction. You know how 5 over 10 is 1/2 or 0.5? Excuse me, but we write it as 1/2. We reduce that fraction. This is what we're doing when we're simplifying square roots. All right, so for example, the square root of 12. The square root of 12, we do not know what this is as a square root. We could say that the square root of 12 is smaller than the square root of 16 and bigger than the square root of 9. Why would I choose a 16 and a 9? Good. So we can say that we know the square root of 12 has to be bigger than 3 and smaller than 4. So I can tell what the square root of 12 is between. And I could type it into my calculator to get a decimal. But can I simplify square root of 12? Here's what we do. There are two ways to do it. Which way you choose is up to you. The first way uses your perfect squares, and it says that the square root of 12 would have to be equal to, what's the largest perfect square that goes into 12? Is 3 a perfect square? It's okay. Perfect squares are 1, and then 2 squared is 4, 3 squared is 9, 4 squared is 16. So just looking at the first 4 perfect squares, will any of those 4 go evenly into 12? Yes. So we could rewrite square root of 12 as 4 times 3. Oh, sorry. No, I meant goes into the radicand evenly. All right. So now that I've got 12 as 4 times 3, I can rewrite this as the square root of 4 times the square root of 3. The square root of 4 is 2. No square root needed anymore. Square root of 4 is 2. So this would be 2 times the square root of 3, or just 2 square roots of 3. And this is my simplified square root. The second way is to use the prime factorization. This is my favorite method because once you have it down, it works no matter what is in the radicand. Like I don't have to guess and check which numbers go in evenly. So the square root of 12 would be equal to. And off to the side, I'm going to do the prime factorization of 12. 12 is 2 times 6, which is 2 times 3. So 12 is the same as 2 times 2 times 3. Now, when you take a square root, you're essentially asking what number is being multiplied by itself. And as I look at the prime factorizations, which number is being multiplied by itself? Well, it's a 2 times 2. So this is 2 square root of 3. Say again, Summer? Okay. Since I have 2 2's here, that 2 can come up. So 2 pairs underneath makes 1 outside. Do ya? Okay. Let's try some problems. So the main skill that we're going to practice here is your ability to simplify these square roots. They will be square roots with numbers and some square roots with variables. But the idea here is that you can simplify these square roots. So in our first example here, we're going to do the square root of 20. I like the prime factorization method, so I'm going to continue on with that. 20 is 4 times 5, and 4 breaks into 2 times 2. So this would be the square root of 2 times 2 times 5. Since I have a pair of 2's, that 2 can come out front, and I have the square root of 5 left. A pair lets 1 come out. Summer, you would have done the square root of 4 times 5, which is the square root of 4 times the square root of 5, or 2 square roots of 5. the square root of 98. And this is one where I'm talking about, if you're going to do perfect squares here, you're in for some guessing and checking, right? Yeah. So I'm going to do, this is why I like the prime factorization. Prime factorization, I look at 98 and I say, okay, it's even. And because it's even, I can do a 2 times 49. Ah. Other way around. What do you have 2 of? I have 2 7s. So that would be 7 square roots of 2. Now, if we did it your way, once you had the 2s and then 7 or 49, this would be 2 times 49, or the square root of 2 times the square root of 49. I don't know the square root of 2, but I do know the square root of 49, 7 square roots of 2. If I do example 3, let's say square root of square root of 108. All right, I'm going to do the prime factorization. And that's 2 times 54, which is 2 times 27, which is 3 times 9, and 3 times 3. All right, I have a pair of 2s, and I have a pair of 3s. This means that I can pull out a 2, and I can pull out a 3. This 3 does not have a pair, so it stays underneath the square root. 2 times 3 is 6 square roots of 3. If we're going to use perfect squares, I would say probably I would do a 4 first. This would be 4 times 27, which is the square root of 4 times the square root of 27, or 2 times the square root of 27. But now you've got to recognize that 27 is the square root of 9 times 3, or 2 times the square root of 9 times the square root of 3. Whew. Or 2 times 3 times the square root of 3, or 6 square roots of 3. Either you do this little bit by little bit, or you recognize right off the bat that 36 is the biggest perfect square that goes into 108. And I just don't think you're going to find 36 right away. Yeah, do you see how the prime factorization works better with larger numbers? Yeah, I'm not saying you can't use the perfect squares and that it won't be helpful, but it can be a lot sometimes. All right. Do you want to do a couple more of those, Summer, or are you all right? Want to do a couple more of the long? Okay. You got it. All right. So let's see. Um, 6. Okay. All right. Let's try the square root of 640. Okay. So for 640, I'm going to do 10 times 64 right away. 10 is 2 times 5. 64. Well, what do I know about 64? Yeah, I already know that this is 8 times 8. So even with the prime factorization ones, when I see an obvious square root, I use it. So 8 times 8 times 5 times 2. I've got a pair of 8, so I can pull that 8 out. Neither 5 nor 2 has a pair, so they would both stay under as 5 times 2. So 8 square root of 10. And on this one, even though it's larger, you might pull that 64 out right away. This is why it might be helpful to know both methods versus just one. Right? Because there are kind of advantages to both. I did the square. Just in case I threw it in there, let's talk about what happens if you see a variable. Right? Let's try the square root of 25 x to the third. I could break this up into the square root of 25 multiplied by the square root of x to the third. Do you know the square root of 25? This is 5. X to the third is x times x times x. Remember, if you have a pair, you can pull it out. Since I have a pair of x's, I can pull one outside. Say that again. Not x squared, because a pair inside means one outside. So it would just be 5x square root of x. Here I have 2 and then the square root of 9x to the 4th y cubed. The 2 stays there. Then I've got the square root of 9 times the square root of x to the 4th times the square root of y to the 3rd. Square root of 9 is, what about the square root of x to the 4th? Okay. So I could pull out not 1x, but, well, x squared. And y to the 3rd would be y times y times y. And I have 1 pair, and 1 would need to stay out. Okay? All right. That's all I wanted to get through today, was just the review of square roots and the simplifying of some of those square roots. I did not put many with the variables in because that's not our main skill. I think there's just 1 or 2 challenge questions at like the end of the assignment. Most of your assignment will be simplifying like we did with these numbers. Okay? Any other questions before we end this summer? Okay. All righty. You know you can. All right. You have a good day. Bye, Summer.